Okay, hello Cloud Gurus and welcome to this section of the course. This section of the course is on VPCs. Now it is super important to understand VPCs inside out, both in real life and going into your exam. You're going to get at least 5 to 10 questions on VPCs, as well as VPC architectures, public and private subnets, etc., etc. Now the easiest way to learn VPCs is to go ahead and build our own. So that's what we're going to be doing in this section of the course. Before you go and do your exam, and I mean literally on the day of doing the exam or the day before doing the exam, you should be able to build out your own VPC from memory. If you can do that, then you'll be able to pass the Certified Solutions Architect Associate exam. So the question has to be asked, what is a VPC? And basically, just think of a VPC as a virtual data center in the cloud. Amazon's virtual private cloud, Amazon VPC, lets you provision a logically isolated section of the Amazon Web Services cloud where you can launch AWS resources in a virtual network that you define. And you have complete control over your virtual networking environment, including selecting your own IP address ranges, creation of subnets, and configuration of route tables, as well as network gateways. And you can easily customize the network configuration for your Amazon virtual private cloud. For example, you can create a public-facing subnet for your web servers that has access to the internet, and then you can place your back-end systems such as your databases or your application servers in a private-facing subnet with no internet access. So in doing that, your web servers are exposed to the internet, but your sensitive application and database servers are not exposed to the internet. And you can leverage multiple layers of security, including security groups, as well as network access control lists to help you control access to Amazon EC2 instances in each subnet. And additionally, you can create a hardware virtual private network or VPN connection between your corporate data center and your VPC and leverage the AWS cloud as an extension of your corporate data center. So why don't we go ahead and have a look at what a VPC looks like. Okay, so here's a diagram of a VPC. So this red line represents a region. So this is US East 1. And inside this region, we have our VPC. And on the outside of our VPC, we have two ways of connecting into it. We have an internet gateway and a virtual private gateway. And both of these connections go to our router in our VPC. I'm going to call it router because that's what Americans call it. And the router then directs traffic to our different route tables. And then our route tables will then direct traffic through our network ACLs. So this is our first line of defense. These also act like firewalls, very much like security groups. But if you remember from the EC2 part of the course, we looked at security groups and they were stateful. Network ACLs are stateless. They allow you to do allow rules as well as deny rules. And you can block specific IP addresses on your network ACL. We then move over to security groups, which are stateful, and that acts as a further line of defense against our EC2 instances. And then here we have two different subnets. We have a public subnet, so internet traffic is accessible, or the internet is accessible for any EC2 instances in our public subnet. And then we have a private subnet, and this simply means that our EC2 instances cannot access the internet on their own. And you can still connect into these EC2 instances, but the way you would do that is you would go through here all the way into your public subnet, and then you would SSH directly from an instance in here to an instance there. So that's the way you would access it. And we're going to have a look at how that works. And in Australia, we call those jump boxes, and the rest of the world, we call it Bastion host. So a Bastion host is just an EC2 instance in a public subnet that you then use to connect to an EC2 instance in a private subnet. So this is all a VPC is. It's a collection of internet gateways, route tables, network ACLs, security groups, EC2 instances, and then of course your public subnets and your private subnets. Now you will note here this IP address is 10.0.1.0 and this one here is 10.0.2.0. So they are completely different subnets. And the Internet Assigned Numbers Authority actually has 3 different sets of IP addresses that are reserved for private IP address ranges. So these are ranges that are available on private networks. They're not available on public networks. And the first is 10.0.0.0, and this is a 10/8 prefix. Now Amazon don't allow /8. The largest subnet that you can have inside a VPC is a /16, and we'll come and have a look at that in a second. We then could also use the IP address range 172.16.0.0. This goes all the way up to 172.31.255.255. This is a /12. And then we have the most famous, which you're probably used to from your own home networks, which is 192.168.0.0. And this goes all the way up to 192.168.255.255. And this is a /16 prefix. Now, if you don't know what that means, I want you to go over to your browser. So this is a website I like to use. It's called cider.xyz. So if you just type this into your browser, cider.xyz, you'll be able to create subnets in here. So if we're going to use 10.0.0.0 and we're going to use a /16, straight away it's going to tell us what our first IP address is, what our last IP address is, how many available IP addresses that it gives us, and it'll also give us the subnet mask. And we're going to be using this throughout the rest of the course because this is the largest subnet that you can use within your VPC, and it's also the most commonly used amongst corporate networks. So we're going to use 10.0.0.16, and then we'll go up for every subnet. So this could be our public subnet, and then 10.0.1.0 could be our private subnet, etc., etc. Likewise, you can go up here, you can change this to a /24. You can see the first IP, the last IP, and then how many IP addresses are available in a /24 subnet. We can go all the way up to a /28. A /28 is the smallest subnet that you're allowed to have within Amazon VPC. And again, you don't need to understand any of this going into the Certified Solutions Architect Associate exam. However, going into the Certified Advanced Networking Specialty exam, you will need to be able to do subnetting. You'll need to be able to calculate the first IP address, the last IP address, and then how many IP addresses are in that subnet. And we do cover off how to calculate these values in the Certified Advanced Networking Specialty course. So if you do have the time after doing your Certified Solutions Architect Associate and you really enjoyed the VPC section, definitely check that course and that certification out. It is one of the most valuable certifications in tech right now because it is one of the hardest to get. So don't worry if this diagram still looks a bit scary. Like with anything with AWS, the best way to learn it is to go ahead and start building out your own VPC, and that's exactly what we're going to do in the next lecture. So what can we do with the VPC? Well, we can launch instances into a subnet of our choosing, so we can choose our own subnet address ranges. We can assign custom IP address ranges in each subnet, which is what I just said. We can configure route tables between our subnets. We can create internet gateways and attach it to our VPC. And we get much better security controls over our AWS resources. And we can assign security groups to individual instances, but we can also have subnet network access control lists, or ACLs, as well. And we're going to look at how we can use those in a lecture coming up. So in all the rest of the sections of the course, we have been using our default VPC. And what we're going to do in the next lecture is we're going to create our own custom VPC. And you might be wondering what the difference is between a default VPC and a custom VPC. Well, the default VPC is super user-friendly. It allows you to immediately deploy instances. You don't need to know anything about networking to be able to provision an EC2 instance in the AWS console. So that's why Amazon give us a default VPC. They're trying to make it easier for our developers to use AWS. And all subnets in a default VPC have a route out to the internet. That means they're all internet accessible. And each EC2 instance has both a public and private IP address. So those are the main differences. If you do delete a default VPC, you can recover it now, so it's not a problem if you do delete it. Try not to delete it though. In the next lecture, what we're going to do is create a custom VPC. We can also do VPC peering, which we're going to look at later on in this section of the course. This allows you to connect one VPC with another via a direct network route using private IP addresses, and instances behave as if they were on the same private network. And you can peer VPCs with other AWS accounts as well as with other VPCs in the same account. And peering is always in a star configuration. This means you have one central VPC that peers with 4 others. You can't do transitive peering. You might be wondering, what does that mean? You can also peer between regions as well now. So you can have one VPC in one region and you can have another VPC in another region, and you can peer across regions. So do bear that in mind as well. So let's have a look at what transitive peering means. So let's look at VPC B. So VPC B is paired with VPC A. So the instances in this VPC can talk to the instances in this VPC. Likewise, the instances in VPC A can talk to the instances in VPC C. However, in order for VPC B to talk to VPC C, it can't go through VPC A. Instead, what you have to do is you have to do another peering connection directly between VPC B and VPC C. So transitive peering just means you can't peer through one VPC to another. You must set up a new peering relationship. And again, we're going to have a look at VPC peering in this section of the course. So don't worry if this has overwhelmed you a little bit. Like anything with AWS, the easiest way to learn about VPCs is to go ahead and create your own and get your hands dirty. That's what we're going to do in the next lecture. So just remember the following. I want you to think of VPCs as a logical data center in AWS. It consists of IGWs, so internet gateways, or virtual private gateways for VPNs, and then route tables, network access control lists, subnets, and then security groups. One subnet always equals one availability zone, so 10.0.1.0 will be in US East 1A, for example. 10.0.2.0 might be in US East 1B, etc. So to be clear, you cannot have a subnet stretched over multiple availability zones. However, you can have multiple subnets in the same availability zone. So when we say one subnet equals one availability zone, all I mean there is you cannot have one subnet spread across multiple availability zones, but you can definitely have multiple subnets in one availability zone. So I hope that makes sense. Remember that security groups are stateful and network access control lists are stateless. That basically just means with network access control lists that you can add deny rules as well as allow rules. And when you open up a port on inbound, it doesn't automatically open up a port on outbound. You have to go in and add that in as well. And also remember with VPCs, you cannot have transitive peering. So if you have VPC A who needs to talk to VPC B, who then talks to VPC C, VPC A has to, if VPC A wants to talk to VPC C, you have to create a peering connection between the two. So that's it for this lecture, everyone. In the next lecture, what we're going to do is we're going to go in and get our hands dirty, and we're going to build our own custom VPC. It's going to be super hands-on. You're going to have lots of fun. So if you've got the time, please join me in the next lecture. Thank you. Okay, hello Cloud Gurus and welcome to this lecture. So in this lecture, we're going to create our own custom VPC. This is going to take slightly over 20 minutes, so we are going to break it into two parts. So this is a lab and you will need to log into the AWS console. Okay, so here I am in the AWS Management Console, and I'm going to do the rest of this section of the course out of the Ohio region. The reason for that is I'm currently in Austin, Texas. We have an office out here, and Ohio gives me the lowest latency. So we're going to find VPCs. If we go into services, we're going to scroll down, we're going to find networking and content delivery, and VPC is always going to be the top one under there. So go ahead and click in there. And this will load our VPC splash screen, and it looks a little bit like this. We can see all our resources by region, but we can also see all regions. So we can click on here and it'll load all our VPCs in all the regions around the world. Now you can go ahead and launch a VPC wizard, but the problem with doing that is you're not going to learn anything. And we want to be able to build a VPC all by ourselves. So if we click on our VPCs in here, we can see that we've got one VPC, and this is our default VPC. If we have a quick look at our subnets, we can see that it's got 3 subnets. They are all using this CIDR address range, so it's 172.31 and then .16.0, 172.31.0.0, and then 172.31.32.0. So these are /20. This gives us 4,091 available IP addresses. Now, you will note that each subnet is in a separate availability zone. And if we click on here, we can see our default route table. So this is also a route table that's created for us when we have our default VPCs. We can see our internet gateway. This allows our VPC to talk to the internet. And down here, we've got our network access control list. And then down here, we've got our security groups. And we can see a web DMZ security groups because I have used this VPC before. So let's go ahead and create a VPC. And what we want to see is what resources are created by default when we create our VPC. So what are we going to call this VPC? Well, I'm going to call it a Cloud Guru VPC. And in here, we've got our IPv4 CIDR address block. So what I'm going to do is I want the biggest address block possible. So I'm going to go 10.0.0 and then / and then 16. And in here we can also do a IPv6 CIDR block. That's entirely up to you. I am going to use the Amazon provided IPv6 just so we can see some options later. And in here we've got our tenancy. So if we want everything to be on dedicated hardware, we would click on dedicated. That is going to cost you a fortune though. I'm going to use the default, which is multi-tenant. So we are sharing our underlying hardware with other AWS customers. What I'm going to do is go ahead and hit create, and that has now created our VPC, and we've got a new VPC ID. So let's go back and see what has been created. Let's see if there's been a subnet created. And in here you can see this VPC, all these three subnets are still our default VPC. We cannot see our new VPC in here. So when we create a VPC, it doesn't create any subnets. If we click on root table, however, we'll be able to see if we go over here and we just extend this across, you'll be able to see here. So here is our root table. This belongs to the A Cloud Guru VPC, and this one belongs to our default VPC. So it has created a root table. What about an internet gateway? Well, no, there's no A Cloud Guru VPC in there, so it hasn't created an internet gateway. If we go down and have a look at our network ACLs, we can now see that this does have a network ACL, a default network ACL that's been created. So it's the A Cloud Guru one. And likewise with a security group, we can see just by moving this across, it has created a security group. It's just showing us our VPC ID here. It's not giving us the name, but that's our A Cloud Guru VPC in there. So essentially, when we create our VPCs, we're creating by default a root table, a network ACL, and a security group. So this is what our VPC looks like now. Ignore the region, but everything else is identical. So we've got a router or a root table, we've got a network ACL, and we've got a security group. So that's what our VPC currently looks like. Now, in order to be able to use this VPC, we need to go in and create some subnets. So let's go ahead and do that now. So in order to be able to create our subnets, we go over here to subnets, and note these three subnets that already exist. They're using the 172.31. So these are the subnets that were created with our default VPC. They're not using the 10.0.0.0 range. So what we want to do is go ahead and hit create subnet. In here, we're going to give our subnet a name. Before we do that, let's click on VPC and click on A Cloud Guru VPC. And in here, you can go ahead and click on your preferred availability zone. Now, it is worth noting that let's say we've got two different AWS accounts. My US East 2A could be completely different to your US East 2A. And the reason Amazon do that is they randomize the availability zones, because everyone was always going to pick 2A and 2B as their sort of first and second preferences, and they want to make it completely random. So in one AWS account, a certain availability zone such as US East 2A could be a completely different availability zone, even though it's got the same name in another AWS account. So do just bear that in mind. So I'm going to use US East 2A, and I'm going to give it a subnet address range of 10.0.1.0, and then I'm going to give it a /24. And in here, I'm going to give it my name. So it's already giving me my name as Ryan Cronenberg. I want to make it very easy to read. So I'm going to do 10.0.1.0 and then hyphen, and then I'm going to also put in the name of the availability zone. So I'm going to call it US East 2A. And then that way I can, just by looking at the name, know both the CIDR address range as well as what availability zone that it's in. And so then I'm going to go ahead, and you can go in here and assign IPv6 if you want. I'm not going to do that. I'm just going to be using IPv4. So I'm going to go ahead and hit create. And that has now created my subnet. I can go ahead and hit close. And now we can see it in here. And if you do want to sort by VPC, just click in here, and then everything will be sorted by our VPCs. I'm going to go ahead and create one more subnet. And again, in here, I'm going to select my VPC. And I'm going to put this in US East 2B. And I'm going to give it a address range of 10.0.2.0/24. And the name I'm going to give it is going to be 10.0.2.0, then hyphen, and then it's going to be US East 2B. And I'm going to go ahead and hit create. So that has now gone ahead and created my two subnets. You can see them in here. And just by looking at the name, I'm able to see what site address ranges that it's using, as well as what availability zone that it is in. And note that we cannot have a subnet span availability zones. So it's always one subnet equals one availability zone. That comes up an awful lot in your exams. Now, if we scroll across here, there's a couple of things we need to look at. Auto assign public IP address by default has been turned off. So we are going to have to fix that because we're going to have one of these as a public subnet and one of them as a private subnet. And the other thing we should also note is in here, we've only got 251 available addresses. Now, if you remember that website, cider.xyz, if we use a 10.0. Let's just change this to 0.0/24, we should be getting 256 addresses available to us, an actual usable amount of 254. We seem to be missing some. Why do we only have 251? And I'll put a link to this in the resources section of the course, but if you just go over to VPC subnet sizing, in here you can see that the allowed block size is between a /16, which is what we created, and the very top one is a /28, which we covered off in the last lecture. If we scroll down, we can actually go ahead and see some reserved IP addresses. And Amazon go ahead and reserve 5 IP addresses. They reserve the network address, they reserve the network broadcast address, and then they reserve 10.0.0.1 for the VPC router. So that's actually your VPC router's address. And 10.0.0.2 is reserved by AWS, and this is the IP address of the DNS server for your VPC. And then they actually just reserve one more, and they don't explain why, but they've reserved 10.0.0.3. So you're always going to have 5 addresses, and that's why it says 251 addresses instead of 256. So now that we have our subnets, we are going to want to have one that is publicly accessible. It's probably going to be this one. We'll just keep it simple. So 10.0.1.0. Now, in order for this to be publicly accessible, we're going to need EC2 instances to launch in it with public IP addresses. So we're going to need to auto-assign our public IP addresses. So select the one that you want, the subnet that you want, go ahead to Actions, and then just go over to Modify Auto-Assign IP and enable Auto-Assign a public IPv4. And there we go. That has now enabled it, and we are now able to launch EC2 instances into this subnet, and they'll automatically be able to get a public IP address. So this is what our VPC looks like right now. We've got our public subnet 10.0.1.0, and we've got our private subnet 10.0.2.0. We've got our network ACLs, our security groups, our root table, but what we're missing is a way to get into this VPC. So we're going to need to add an internet gateway, and then we're going to have to go in and start configuring our root tables. So let's go over to the AWS console. Okay, so to add our internet gateway, all we need to do is click on Internet Gateways in here. And you can see that there's no internet gateway for our VPC currently. So let's go ahead and create one. And I'm going to call this my IGW, so my internet gateway, and go ahead and hit create. That has now created an internet gateway. You can see my IGW is detached. That's the state that it's in now. So if I go to Actions, I can go attach to a VPC, and I can go ahead and select a VPC. I'm going to select the Cloud Guru VPC, and I'm going to go ahead and hit attach. And that has now attached an internet gateway. I could go ahead and do my IGW2 and create a second internet gateway and hit close. And let's see if I can attach a second internet gateway to my VPC. And if I click in here, you can see that there's no VPCs in this box. So you can only have one internet gateway per VPC. Don't worry about high availability. Amazon completely designed internet gateways to always be highly available. So just remember, you can only have one internet gateway attached to one VPC. I'm just going to go in and delete this internet gateway because we don't need it. So now that we have an internet gateway, we need to go into our root table and configure our main route so we have a route out to the internet. So I'm going to click on here. This is my default route table. And if we click on our routes, we can see 2 routes in here. And essentially what this is doing is it's allowing our subnets to be able to talk to each other. So any subnet that we have inside our VPC using these 2 routes, essentially it means that they can communicate to each other over IPv4 and then over IPv6. If we click on subnet associations and we maximize this just so you can see it a little bit better, it says down here The following subnets have not been explicitly associated with any root tables and are therefore associated with the main root table. So if we were to put a route out to the internet in our main root table, that means that any subnets that we were creating would automatically be associated to our main root table. And what that would mean is that every subnet that we create by default would be public. Now that could be a security concern. So really what we want to do is always keep our main root table as private, and then we have a separate root table for our public subnets. So let's go ahead and do that. So let's go over and create a root table, and I'm going to call this my public root. So this essentially any root, any subnet that's associated with this root table will then be able to talk to the internet. Let's click in here on VPCs, and we're going to create it into our VPC and go ahead and hit create. And we now have two root tables. If we just minimize this a bit more, you can see we've got my public root, and then we've got my other root table, and you can see that this is the main root table and this is not the main one. So anytime we create a subnet, it's always going to be associated with the main, but with our public root, we have to go in and specifically associate our subnets with this public root. First thing we're going to do with our public root is create a route out to the internet. So we could go ahead and hit edit routes, and we can go in and add our routes. So to create a route out, all we do is type in o.o.o.o/ and then O, and then that will give us a destination. And in here we just type our target, and our target will pre-populate with all of these. What we want is our internet gateway, and then we select our internet gateway. And then we can also go in and add our route, and you can go, if you want to do IPv6, you just go : and then / and then O, and that will give us a route out. And again, we're going to do that using our internet gateway, and just click on your internet gateway in there. Go ahead and save your routes, and that has now given you a route out for IPv4 and IPv6 to our internet gateway. And now any subnet that's associated with this route table will automatically become public, both for IPv4 as well as IPv6. So let's go ahead and click on our subnet associations. In here, go to Edit Subnet Association, and we're going to add this subnet to our public route table. And that has now associated that subnet with this route table. So if you go in and click on your main one, you'll be able to see that the only one that's associated with our route table is 2.0. We no longer have 1.0. And 1.0 is now associated with our public route table. And so you can see it in here, 10.0.1.0 is associated to this route table. And guess what? It has a route out to the internet. It's got our o.o.o.o, which points to our internet gateway. So that's how it all works. So we now have a public subnet and we have a private subnet. The next thing to do is to go in and start provisioning EC2 instances. And we're going to create an EC2 instance in a public subnet as well as one in our private subnet. So then we're going to go in and test it. So we just go over to compute, click on EC2. I'm going to launch two different EC2 instances. I'm going to go ahead and launch my instance, and I'm going to use the Amazon Linux 2 AMI. And I'm going to just use a T2 micro. So we're not going to leave everything as default. What we're going to do is we're going to go over to our network. We're going to change this to our VPC. And then we're going to select our public subnet, which is this one, US East 2A. So I'm going to click in there. And then you can see here it says auto-assign public IP address, use the subnet setting, which is enable. So it's automatically going to get a public IP address. Next, we're going to add our storage and add our tags. I'm going to add a tag. I'm just going to call this name, and then this will be web server 01. And then I'm going to go ahead and configure my security groups. Right now, I'm going to, if I click existing security groups, there's only my default security groups. Note that I do not have any WebDMZ security groups in here. That's because my WebDMZ security group was in my other VPC. So security groups do not span VPCs. I'm going to go ahead and create a new security group. I'm going to call it WebDMZ because we're going to need to be able to SSH into this as well as give it internet access. As well as give it HTTP access. So I'm going to add in here HTTP, and then I'm going to go in and hit review and launch. So this has created a new security group that will allow, that has SSH and HTTP open to the world. And then I'm just going to go ahead and launch it. And I'm going to actually do a new key pair because I don't have this key pair on this computer. So I'm just going to call it my new key pair, and I'm going to download that. And then I'm going to go ahead and launch my instance, and that is now launching. And I'm going to go over to View Instances. We're going to launch our second instance. It's going to be an Amazon Linux AMI2. Going to go ahead and hit Next. In here, make sure you change your network to your new VPC. And I'm going to launch this instance into US East 2B. Note, auto-assign public IP address. The last one said enable. This one says disable, and it's using the subnet settings. So we're not going to get a public IP address for this EC2 instance. Let's go ahead and add our storage. I'm just going to leave that as default. I'm going to add my tag and the name. We might just call this my DB server. So this is my database server. I'm going to go in and configure my security groups. I'm going to use an existing security group, but I'm not going to use the web DMZ. I'm going to use the default security group. And then I'm going to go ahead and hit review and launch. And then I'm going to go ahead and hit launch. And I'm going to use my new key pair. So I'm going to use the same key pair as I did for the other one. And I'm going to go in and view instances. Now straight away we can see over here we have a public IP address for this EC2 instance. So let's go in and try and connect to this EC2 instance. Okay, so I'm going to go over to my downloads directory and I'm going to hit enter. And in here I've got my my new key pair. So my new key pair, I am just going to chmod that because this is a new key pair. So I'm going to do the appropriate permission so I can connect in. And there we go. And then I'm just going to clear the screen, and to SSH in, I'm just going to type SSH EC2 user and then @ and then the public IP address. So pasted that in there, then -i, and then it was my new key pair.pem. Hit enter, type in yes, and there we go. I am now SSH'd in to my EC2 instance. I'm going to elevate my privileges to root, and then I'm just going to go ahead and clear the screen. So that is the end for part one. I'm conscious we're about to go over 20 minutes. This is basically what we've created thus far. So we've got our VPC with an internet gateway attached. We've got our two different root tables. One's a public root table and one's our default root table. We've got one network ACL. We've got two security groups. One's web DMZ and one's our default security group. Our EC2 instance that's private is in our default security group, and our EC2 instance that's public is in our web DMZ. And right now we can only connect into the public EC2 instance because we've got a public IP address. So what do we learn in this lecture? Well, we learned that when you create a VPC, a default root table, a network access control list, and a default security group is created. It won't create any subnets, nor will it create a default internet gateway. And just remember that US East 1A in your AWS account can be a completely different availability zone to US East 1A in another AWS account, that the availability zones are always randomized. And then, of course, Amazon always reserve 5 IP addresses within your subnets. You can only have one internet gateway per VPC. And then finally, we learned that security groups can't span VPCs. So that is it for this lecture. In the next lecture, we're going to connect into our EC2 instance that's in our private subnet. So if you've got the time, please join me in the next lecture. Thank you. Okay, hello Cloud Gurus, and welcome to this lecture. In this lecture, we're going to look at part 2 to creating your own custom VPC. So far we've created a VPC. We've got a public subnet, we've got a private subnet, we've got instances in both. But right now, all we can do is SSH in to our public instance, in our public subnet. We have no way of communicating to our private instance. So let's go ahead and figure out how we can do that. So I'm back in the AWS Management Console, and if I just go over to Services and go over to EC2, and we can see that I've got 2 running instances. I've got one in my public subnet, which is this one, my web server in US East 2A, and I've got one in my private subnet, my database server, and it does not have a public IP address. What it does have, however, is a private IP address. Now, if I tried to SSH into it from my web server, it's not going to work, and the reason for that is they're in 2 separate security groups, and by default, the security groups do not allow access to each other. So what we might want to do is go ahead and create a new security group. Because this is my database server, we should probably have a database security group. Okay, so we're going to call this my DB security group, my database security group, and we're going to give it the same description as well, so my DB security group. The VPC, we're going to choose our A Cloud Guru VPC, And in here we add our rules. So what do we want to be able to communicate to EC2 instances inside this security group? Well, let's say the first thing we want is ICMP. We want to be able to ping EC2 instances inside this security group from our WebDMZ security group. How do we allow our WebDMZ security group to ping? Well, in here we've got to enter in our source. Now our source we can actually enter in SG and then type our WebDMZ security group in there, or we can actually use the IP address range, which is what I'm going to do. So it's 10.0.1.0 and then /24. And then I'm just going to delete that one there. And then actually what I'm going to do is I'm just going to type that out manually, and I'm going to copy this into my clipboard so I don't have to keep typing it again and again and again. So we're going to do this for ICMP. Then we're also going to do it for, let's do HTTP. We want to be able to talk to our our database servers using HTTP. Maybe we're installing, management software to manage MySQL, for example. We also want to do it using HTTPS. So HTTPS in here. And again, we'll paste it in there. And then we also want SSH. So we'll type in SSH and our source address there. And then finally, we want to be able to communicate to our database servers using MySQL or Aurora, so port 3306. And you can see our ports are automatically populated in here, so you don't need to know your port numbers, but it's always good to know the common port numbers like HTTP, HTTPS, SSH, and MySQL. And so there we go, we've got it all set up. And then all we need to do is scroll down and go in and hit Create Security Group. And that is now creating our security group. That has now created a new security group, my database security group, which is in my default VPC. Next thing I want to do is just go over to EC2, and I want to move my DB server. I want to go ahead and change to networking, and we're going to go ahead and change security groups. And I'm going to basically add my DB and remove it from my default security group. And there we go. I'm going to go ahead and hit add. So that has now moved my security groups. Let's go down here and grab this private IP address. I'm just going to copy that into my clipboard. And then what we want to do is we want to SSH into our public web server. So I'm SSH'd in from the last lecture. And then all I'm going to do is I'm going to type in ping, and I'm going to paste in the private IP address. And you can see that is now pinging. So I am now able to communicate from my public web server to my private web server. The next thing we might want to do is if we just clear the screen, we want to SSH over to our private web server. Now to do that, what we're going to need to do is put somehow access our key in order to do that. So I'm going to put the private key on this web server. Normally you would never do this in production. What you would do is use a Bastion host, and we're going to look at Bastion hosts later on in this section of the course. But just to keep things simple, we're all learning about VPCs. What I'm going to do is I'm going to open up my private key, and I'm going to copy it into my clipboard. So I'm in my downloads directory. Here's my private key in here. I'm just going to go ahead and hit open. I'm going to open this with a text editor, and you can see it in here. And I'm just going to copy it into my clipboard. And then in here, I'm just going to do nano my private and then key.pem. So we're creating a file. I'm going to paste it in here, and then I'm going to go ahead and hit Control X, hit yes, and then enter. And then I'm going to chmod it to 400. So my private key pair. If we type in ls, you can see it in there. Grab your private IP address to your database server. And then all we want to do is type SSH, EC2, and then -user, and then @ and then the private IP address, then -i, and then my pvkey.pem. Type yes in here. And there you go. You are now SSH'd into your database server, which is in a private subnet. So essentially you're SSHing into your public server and then SSHing into your private server. Now there's a much more secure way to do this using Bastions, because the last thing you want to do is be saving private keys on your public web servers. I mean, what would happen if they got hacked? I'm just going to go ahead and elevate my privileges to root, clear the screen. Now what do you think would happen if we ran a yum update? This is in a private subnet, don't forget. And this is going to take a little bit of time, but it's going to completely fail and time out. And that's because we're in a private subnet that has no route out to the internet. But at the same time, how are we going to do yum updates? How are we going to go in and install software? We want to maybe go in and install MySQL. This is a database server after all. How do we do that? So that's what we're going to look at in the next lecture. We're going to look at NAT instances versus NAT gateways. NAT instances are fairly out of date, but they still do come up in the exam. I had a question on them just 2 weeks ago when I did my exam, and that has now failed. So that's what we're going to cover off in the next lecture, NAT instances versus NAT gateways. If you've got the time, please join me in the next lecture. Thank you. Okay, hello Cloud Gurus and welcome to this lecture. This lecture is on NAT instances and NAT gateways. So NAT just stands for Network Address Translation. And essentially what we want to do is enable our EC2 instances in our private subnets to still be able to go out and to download software. And in order to do that, they need a way of communicating to our internet gateway. However, what we don't want to do is make our subnets public. We still want a degree of control. So what we're going to do is create these things called NAT instances and NAT gateways. Now, 9 times out of 10 or in the real world, you'll always be using NAT gateways. NAT instances are individual EC2 instances that do this, whereas NAT gateways are highly available. They're not just one EC2 instance. They're spread across multiple availability zones. They're not dependent on a single instance. NAT instances are completely on their way out, but they are still in the exam. I still had a question on NAT instances literally like 2 weeks ago. So you do need to know the difference between a NAT instance and a NAT gateway. A NAT instance is literally just a single EC2 instance. A NAT gateway is a highly available gateway that allows you to get allows you to have your private subnets communicate out to the internet without becoming public. So what we're going to do is we're going to start with NAT instances. I'll show you how to create one, and then we're going to move on to NAT gateway. So I'm back in the AWS console. We're going to go over to services. I'm going to go to EC2. We're going to go ahead and launch an instance. We're going to launch this instance into our public subnet. We're going to go over to community AMIs, and in here we're going to type in NAT and hit enter. And this will give us our NAT instances. So go ahead and select the very first one. We're going to leave everything else as default. I'm going to change obviously the VPC over to our custom VPC, and I'm going to make sure I launch this into my public subnet, and that will also give me a public IP address for this instance. Next, I'm going to add my storage. I'm going to add my tags. I'm going to go in and give this a name. I'm going to call it NAT underscore and then instance. And then I'm going to go ahead and add it to my security group. I'm going to do an existing security group. We're going to put this into our web DMZ security group. I'm going to go ahead and hit review and launch. It's asking me if I want to boot from general purpose SSD. I'm just going to click the second one. I've never actually seen this before. Maybe it's just the AMI that I'm using, but I'm going to go ahead and just hit launch. And then I'm going to use my new key pair, which I got in the last one, and I'm going to go ahead and launch that instance. So that instance is now being launched, and you can see that it is launching into US East 2A, and it has a public IP address. While I wait for this to come up, I just want to show you something. So I've put a link to the resources section to this page in the resources section of the course. This will explain all about NAT instances. But essentially, we've just gone through the process of setting up a NAT instance. We've been using the Amazon Linux community AMI. If you scroll all the way down, it's going to tell you about disabling source and destination checks. And each EC2 instance performs a source and destination check by default. And this means that the instance must be the source or the destination of any traffic that it sends or receives. However, a NAT instance must be able to send and receive traffic when the source or destination is not itself. Therefore, you must disable source destination checks on the NAT instance. So basically, our NAT instance is acting as a gateway. It's acting as a gateway. I hate using that term, but it's acting as a gateway to our internet gateway. It's acting as a bridge between our private subnets through our public subnet to our internet gateway. So what we need to do in order to make that a gateway is we need to disable our source and destination checks. So in order to do that, let's click on our NAT instance. You can see that is now running. I need to go over to actions and go over to networking, and in here I need to change my source and destination check, and I'm going to go ahead and disable it. So that has now disabled it. So now, in order to get my database server to talk to my NAT instance, what I need to do is create a route. And I need to create a route in my default route table so that our EC2 instances can talk to our NAT instance. So let's go over to our VPC, which is under Network and Content Delivery. Then we're going to go over to our route tables in here. We're going to go to our main route table for our custom VPC and go in here. And in here, we're going to go in and add our routes, go and edit your route and go and add a route. And we're basically going to say if we want to go out to the internet, so we want o.o.o.o/o, then what are we going to do? Well, we're going to use an instance. And what instance are we going to use? We're going to use our NAT instance. And so we're going to go ahead and hit save route. Okay, so now that I've done that, I've got a route out, hopefully, to the internet in my main route table. So in my main route table, we're saying go over to this Elastic Network interface. So let's go back over to services, go back over to EC2, and I want you to grab the public IP address of your web server. And then what you want to do is go ahead and SSH in using this public IP address. So I'm just going to SSH EC2-user and then at my public IP address and then using my key. And that has now SSH'd in. I'm going to elevate my privileges to root. I'm going to clear the screen. Then I'm going to do, if I type in ls, I still have my private key from the last lecture. Then I'm going to do exactly the same command, SSH EC2-user and then at. And it was 10.0.2. I think it was 235 from memory. And then I'm going to use my private key, which is my pvkey.pem. Don't forget your private IP address will be completely different to mine, so do make sure you're using the right one. And I've now SSH'd in. Again, I'm going to elevate my privileges to root. I'm going to go ahead and clear the screen. And now I'm going to go and run a yum update. And if this works, it means we've got a route out to the internet. And there you go. It is now using my NAT instance to go in and create, basically go in and do an update to the operating system for my EC2 instance. And that has now finished updating. Now, the problem with this architecture is that this is a single virtual machine. It's a small virtual machine, so it could get easily overwhelmed. Imagine if we had thousands of EC2 instances in private subnets all trying to download things at once, and it's all connecting through this. This NAT instance is a massive bottleneck, and it's just got a single point of failure. If I go in and terminate this instance, it's now going ahead and terminating, and that has now terminated. If I go back over to my terminal window and if I run a, let's say yum install httpd -yes, so I'm trying to install Apache, you're going to see that it's going to time out because it no longer has a route to that NAT instance. What we might want to do is just go back over to our route table and remove that route because that NAT instance is now dead. So we go over to our route tables and we click on our main route table and click on routes. And you can see here the status has turned into a black hole. And the reason it's a black hole is because this instance no longer exists. So let's go ahead and remove this route and go ahead and hit save. We're now going to go ahead and close that. So how can we fix this? How can we make it so that we have a much more highly available and scalable solution? Well, let's go over to NAT gateways. We're going to go ahead and create a NAT gateway. So first of all, ask us what subnet do we want this to be in? And of course, we're going to want this to be in our subnet that is public. Now, annoyingly, the UI just gives us the subnet ID. So what I might want to do is just go back and confirm which subnet is my public one. So it's 10.0.1.0, so it's ending in AEE. So I'm going to go back over to my NAT gateway. I'm going to go ahead and create it. And in here, I'm going to choose AEE. So that's my public subnet in there. And then I'm going to create a new Elastic IP address, and that will then attach it to my NAT gateway. And then I'm going to go ahead and hit create NAT gateway. And that has now been created. We are going to need to edit our route tables to point to this NAT gateway. So let's click on edit route table in here. And we're going to go ahead and edit our main route table. We're going to give it a route out to our internet. So we're going to add our route. We're going to go o.o.o.o/o. And in here, we're going to change the target and we're going to click NAT gateway and then we can see it in there. We're going to go ahead and hit save route and hit close. Now, NAT gateways can take some time to be set up. You can click in here and you can see that the status is pending. I'm going to pause the video while I wait for this NAT gateway to come back up. and then I'm going to go back over to my private EC2 instance, and then I'm going to go in and try and install MySQL. Okay, so that NAT gateway is now available. I'm going to go over to my private EC2 instance. Okay, so I'm back in here. I'm just going to clear the screen. I'm going to go in and go yum, and then I'm going to type install and then MySQL and then -yes. And there we go. It's now using my NAT gateway to install MySQL Server. So on to my exam tips. NAT instances are completely out of date, but they are still in the exam. I literally just did the exam 2 weeks ago and I had a question on NAT instances. Not many people use them anymore. And the reason that is there's a few issues, and we'll go through those in a second. So just remember with NAT instances, when you create a NAT instance, you need to disable your source and destination check on the instance. Your NAT instance must be in a public subnet, and there must be a route out of the private subnet to that NAT instance in order for this to work. And the amount of traffic that the NAT instance can support depends on the instance size. And if you're bottlenecking, all you need to do is go in and increase the instance size of your NAT instance. And you can create high availability using auto-scaling groups and multiple subnets in different availability zones and a script to automate failover. So it is definitely possible, but it is a pain in the butt. And NAT instances are always behind a security group. So we put our NAT instance into our web DMZ security group. NAT gateways. NAT gateways are redundant inside the availability zone. They're not a single EC2 instance. They can survive failure of the EC2 instances that power NAT gateways. So they are redundant inside the availability zone. That being said, though, you can only have one NAT instance one NAT gateway inside one AZ. NAT gateways cannot span AZs, and we'll come to that in a second. NAT gateways are definitely preferred by the enterprise. They start with a throughput of 5 gigabits per second, and they scale currently to 45 gigabits per second. That will increase throughout the year. Don't worry, you'll never be quizzed on like configuration maximums inside AWS. This isn't a VMware exam. Just remember though that it does scale automatically. You don't need to go in and patch the operating system for your NAT gateways. You do have to do that for your NAT instances. Your NAT gateways are not associated with any security groups. We didn't have to go in and add it to my web DMZ security group. Your NAT gateways are going to automatically be assigned a public IP address, and you just need to go in and update your route tables for your NAT gateways, and there's no need to disable your source and destination checks for your NAT gateway. And then finally with NAT gateways, just remember if you have resources in multiple availability zones and they share one NAT gateway, in the event that the NAT gateway's availability zone is down, then your resources in the availability zones, in the other availability zones, are going to lose internet access. So if you only have one NAT gateway in one availability zone, and it is a single point of failure, you should always have a look at having multiple NAT gateways and create an availability zone independent architecture. And so you want to create a NAT gateway in each availability zone and configure your routing to ensure that resources use the NAT gateway in the same availability zone that they're in. And we'll talk a bit more about that more in the high availability section of the course, which is the next section of the course. So always try and use NAT gateways over NAT instances, but do be aware that NAT instances are still going to be tested in your exam. So that is it for this lecture, guys. If you have any questions, please let me know. If not, feel free to move on to the next lecture where we're going to look at network access control lists. Okay, hello Cloud Gurus and welcome to this lecture. In this lecture we're going to look at network access control lists versus security groups. So this is what our environment looks like right now. We've got our NAT gateway, it's sitting in 10.0.1.0, it's got a route out to the internet, and we've got our instances sitting in our private subnet, and it has a route pointing to the NAT gateway, which then has a route out to the internet. Let's go over to the AWS console. So I'm over in the AWS console, let's go over to services, and we're going to go over to our VPC, and we're going to have a look at our network access control lists in our VPC. Network access control lists are under security, and we'll be able to see our two network access control lists, and they're both our default NACLs, and one sits inside our custom VPC, one sits inside our default VPC, and they're associated by with two subnets and three subnets respectively. So to view our default NACL, just click on it, and you'll be able to see in inbound rules. And you'll see here we've got rule numbers. Now rule number 100 is for IPv4, because you can see the source in here. And rule 101 is for IPv6. And Amazon always recommend that you use increments of 100. So if you were to add another rule, you would add for IPv4 a rule number 200, or for rule IPv6 you'd add rule number 201. If you do want to make it so you can see it a bit better, just click on this icon in here. Our outbound rules has similar things, so rule 100, rule 101, these are our allow rules, these are our deny rules. So in order to go ahead and start using network ACLs, let's create a new network ACL. I'm going to call this My Web NACL. And we're going to select the VPC that it's going to go in. So I'm going to use the CloudGuru custom VPC, and I'm going to go ahead and create it. Now, what do you think our new network ACL will look like in terms of its rules? If we click in here, you can see automatically the inbound and outbound rules is to deny everything. So we're going to deny everything by default. So remember that whenever you create a new network ACL, you're going to deny everything. Okay, so let's go ahead and test this, and we're going to test this by setting up a web page on our web server. So if we just go over to EC2, grab the public IP address of your web server, we just need to log into it and go ahead and install Apache and create a little web page. So I'm actually still SSH'd into my private database server, and you can actually just type in exit and then exit, and that will take you back to your web server. So you can see I'm now on a different IP address. I'm on 10.0.1.89. So I am on my public web server now. And I'll just type in service, HTTPD, and then status to see if it's in running. And it hasn't even been installed. So what I need to do is just type yum install and then HTTPD and then -yes. And that will go ahead and install HTTPD. Then we want to go, and I'll just clear the screen so it's easier to see. So we want check config, and then HTTPD, and then on. And then we want to run service, HTTPD, and then start. That'll start our service. Then if we just go over to our cd var www HTML directory, and in here we can see that we don't have anything. So all I'm going to do is I'll just do this in nano actually. So nano index.html. We're going to go ahead and create a little web page. So I'm just going to type HTML and then header and then hello cloud gurus. And then I'm going to end my header. And then I'm going to end my HTML. And there we go. So now all I'm going to do is exit. Yes, I'm going to save it and hit enter. And if we do ls, we can see our index.html. And if we cat our index.html, you'll be able to see the code inside it. So I'm back over in my calendar. If I just type it in here, I should be able to see our web page. So there we go. Hello, Cloud Gurus. Okay, so I'm back in the AWS console, and the reason that is working, let's just go over to our VPC section and go over to our network ACLs. So that subnet is currently associated with our default subnet, and our default subnet has the inbound rule to allow everything. So it's going to allow all traffic in here. That's why HTTP can go through this subnet. What we're going to do is we're going to move our subnet over to this network ACL, and then we're going to start experimenting. So if we just go into this network ACL, and what we can do is click on subnet associations. We can edit our subnet associations, and we're going to associate this subnet, so 10.0.1.0, to this network ACL. So I'm going to go ahead and hit edit. And now we can see that that is now associated with this subnet. If we click in here, we can go back over to our default subnet and have a look. And you can see now that it's no longer associated with our default subnet. It has now moved over to our web network ACL. And if I go back to my web page and I refresh, it's just, you can see down here it says connecting. It's just going to time out because currently we haven't set up this network ACL to allow HTTP traffic to come through. And you can see now it says this site can't be reached. So we are now no longer able to access that website. So how can we fix this? Well, we need to add some rules to allow us to be able to see HTTP. So we're going to click on Edit Inbound Rules, and we're going to start adding our rules. I'm going to start with rule 100, and they go up in increments of 100. And we're going to allow port 80 in from the source all addresses. And then I'm going to do the same with rule 200, except this time I'm going to allow HTTPS, so port 443. And then finally, I'm also going to allow SSH in. So I'm going to allow port 22, and we're going to allow that in from the world. So let's go ahead and hit save. And now what these rules are doing is it's allowing us to connect in on port 80, port 443, and port 22, but it's only allowing inbound. It's not allowing outbound. So we need to go and add some outbound rules as well. And we're going to start with rule 100, and we're going to allow port 80 in here. And then we're going to add a rule, so we're going to allow rule 200, and then in here we're going to allow port 443. And then in here we're going to add our rule, so we're going to add a third rule, and this is where we add what's called our ephemeral ports. And I'm going to explain what they are in a second, but we're just going to type in here 1024 and then do 65535. So those are our ephemeral ports. I'm going to go ahead and hit save. So let's talk about what ephemeral ports are. So Wikipedia has a pretty good explanation here. It talks about ephemeral ports as short-lived transport protocol port for IP communications, and ephemeral ports are allocated automatically from a predefined range by the IP stack software. It then goes on to talk about servers. So it says on servers, ephemeral ports may be used as the port assignment on the server end of a communication. So this is what's happening on our web server. This is done to continue communications with a client that initially connected to one of the server's well-known service listening ports, so like port 80 or port 22, etc., etc. It says here that the allocations are temporary and only valid for the duration of the communication session. After completion or timeout of the communication session, the ports become available for reuse. Down here it talks about the different ranges to use for ephemeral ports. You might be wondering why we use the specific range that we use. And if you go over to the VPC documentation, I'll include a link to this in the resources section of the course. You can read about ephemeral ports in here. The reason we use the ports that we did is because a NAT gateway uses ports 1024 to 65535. So that's why we chose that port range. So now I'm back on my little website. If I hit refresh, we get our web page. So we have now associated our subnet to that network ACL, and we've gone in and added our inbound rules and our outbound rules, and we are now able to connect to that over port 80, and we can see here we are able to view our web page content. So I'm back in the VPC dashboard. In here we can see our inbound rules, and we can see what's happening. So the rules are being evaluated in order. So rule 100 is being evaluated before rule 200 and before rule 300, and that's the way it works. And then it denies everything else. So we're allowing in port 80, we're allowing in port 443, we're allowing in port 22, etc., etc. So what we could do is we could go in and edit our inbound rules, and we can go in and add a deny rule. So let's go in and add a deny rule for port 400, and I'm going to deny port 80, and I'm going to deny it to my specific IP address. So you can type what's my IP into Google, and it will give you your IP address straight away. So go ahead and copy that into your clipboard. I'm going to paste that in here, and then I'm just going to do /32, and I'm going to go ahead and change the allow to a deny, and we'll see what happens. So that is now denying my specific IP address through this security group. And so now I'm on my web page, and if I hit refresh, I can still see the page. So why is that? Well, rule 100 here is trumping rule 400. So rule 100 is allowing everything in on port 80. It's not denying my specific IP address, because my specific IP address is at rule 400. So you have to bear that in mind with network ACLs. They're done in chronological order. So if you've got a deny, you have to have the deny before the allow. So I'm back here. Let's go ahead and edit our inbound rules, and we'll change this rule from rule number 400 to rule number 99. We'll go ahead and hit save. So now we've got rule number 99, which is denying my specific IP address, and then it's allowing all other IP addresses. And so if I go ahead and hit refresh in here, you can now see it says connecting, and it's going to time out because it is denying this specific IP address, but it's allowing all other IP addresses in. So this comes up an awful lot in the certified security specialty exam. You need to understand how network ACLs work and how the rules work. And you can have a specific deny, but if you've got an allow allow before the deny, then that rule is not going to work. So you have to have a good understanding of that going into your exam. So before we go on to my exam tips, I just want to remind you of a few things we've learnt in this lesson. So when we created our VPC, a network ACL was created by default, and it's called our default network ACL. And every time we add a subnet to our VPC, it's going to be associated with our default network ACL. You can then associate the subnet with a new network ACL, but a subnet itself can only be associated with one network ACL at any given time. That being said, network ACLs can have multiple subnets on them. So I could go in here and I could go and add a new subnet association. So I could go and add this one. So we can have many different subnets associated with our network ACLs if we wanted. And then, of course, as soon as we do that association and as soon as we make any rule changes, those rules take effect immediately. And just remember that rules are evaluated in numerical order. And if you have a deny first, that's always going to deny, even if you allow it later. If you're going to deny a specific IP address, you want that rule to be evaluated first. Now, this will come up an awful lot in the Certified Security Specialty exam. It doesn't come up in the Certified Solutions Architect Associate exam too much, but it is a good thing to know in real life. I remember that when you're using network ACLs, they're always going to be evaluated before security groups. So if you deny a specific port on your network ACL, it's never even going to reach your security group. So network ACLs always act first before security groups. One last thing I want to show you is if I go to my web server and I run a yum update and then -y, it's not going to work, and the reason for that is I haven't allowed my ephemeral ports inbound access as well. So I'm quickly just going to cancel this. I'm just back in my network ACLs. I'm going to quickly go through and delete this deny rule and save it. And then what we want to do is we want to grab our ephemeral ports, so 1024 to 65535, and we want to allow that in on our inbound rules. So let's go and add this as a rule. And let's just make this rule 400, and we're going to just paste in our port ranges in here. And so it's 1024 to 65535. Go ahead and hit save. And then that is now allowing our ephemeral ports both inbound and outbound. And if I go back to my web server and I type yum update and then -y, that should now work straight away. So that is how we enable yum updates, etc. We need to open up our ephemeral ports both on the inbound and the outbound as well. So let's move over to my exam tips. And so on to my exam tips, and we're basically just going to summarize everything I just said. So your VPC automatically comes with a default network ACL, and by default, it allows all outbound and inbound traffic. And then you can create custom network ACLs, but by default, each custom network ACL denies all inbound and outbound traffic until you go ahead and add rules. And each subnet in your VPC must be associated with a network ACL. And if you don't explicitly associate a subnet with a network ACL, then the subnet is automatically associated with the default network ACL. And you can block IP addresses using network ACLs. You can't do this using security groups. So if you're always given the choice, you use a network ACL to block specific IP addresses. And just remember that you can associate a network ACL with multiple subnets. You can have as many subnets in there as you want. However, a subnet itself can only be associated with one network ACL at a time. And when you associate a network ACL with the subnet, the previous association is removed. And then network ACLs contain a numbered list of rules that is evaluated in chronological order, starting with the lowest number rule first. And network ACLs always have separate inbound and outbound rules, and each rule can either allow or deny traffic. And network ACLs are stateless, so responses to allowed inbound traffic are subject to the rules for outbound traffic and vice versa. So you need to go in and add rules both inbound and outbound. With security groups that are stateful, you don't need to do that, but just by allowing it inbound, it automatically allows outbound as well. So that is it for this lecture, everyone. Hopefully you understand network ACLs in a lot more detail now. In the next lecture, we're going to cover off custom VPCs and elastic load balancers. So if you've got the time, please join me in the next lecture. Thank you. Okay, hello Cloud Gurus and welcome to this lecture. In this lecture we're going to look at custom VPCs and elastic load balancers. Now I appreciate we've been putting off covering elastic load balancers. We're going to cover that off in the high availability section of the course, so in the very next section of the course. However, because we have our VPC configured the way it is right now, I wanted to show you something quickly. Okay, so here I am in the AWS console, and what we're going to do, we're not actually going to provision a load balancer, but we're going to have a look at what we can do. So I'm going to go into EC2, and then I'm just going to go over to load balancing, which is down here, and I'm going to go ahead and create a load balancer. And you get three different types of load balancers. You get your application load balancers, network load balancers, and your classic load balancers. And we're going to do a deep dive on the differences between the three in the next section of the course. For now, let's just go ahead and create an application load balancer. Now in here we can give it a name, so call it my ALB. I'm not actually going to go ahead and create it. And here you've got your scheme. So you can either have this as internet facing or as internal. And you can do your address types, so IPv4 or dual stack, so it supports IPv4 and IPv6. I'm just going to do it as IPv4. If we scroll down, we've got our different availability zones in here. Now, if we go over to our custom VPC, you'll be able to see that we've got US East 2A and US East 2B. Now, if I click in 2B, straight away it's going to give me a warning message. It's saying you're creating an internet-facing load balancer, but there's no internet gateway attached to these subnets that you have selected. So it's basically saying this isn't going to work. If we click in here, we go ahead and hit next. Straight away, you're going to see this error message. It's saying at least 2 subnets must be specified. So this is an important exam tip going into your exams. You have to remember that when you're provisioning a load balancer, you're going to need at least 2 public subnets. So you need at least 2 public subnets in order to create a load balancer. So that's really important to remember going into your exam. Like I said, we're going to cover off load balancers in a lot more detail in the next section of the course. I'm not going to create this just yet. I'm going to go ahead and hit cancel. So that is it for this lecture. In the next lecture, we're going to go ahead and look at VPC flow logs. So if you've got any questions, please let me know. If not, feel free to move on to the next lecture. Thank you. Okay, hello Cloud Gurus and welcome to this lecture. In this lecture we're going to look at VPC flow logs. So what is a VPC flow log? Well, VPC flow logs is a feature that enables you to capture information about the IP traffic going to and from network interfaces within your VPC. And flow log data is stored using Amazon CloudWatch logs, and after you've created a flow log, you can view and retrieve data in Amazon CloudWatch logs. So it's just a way of basically going ahead and storing all the network traffic that's going on in your VPC. And flow logs can be created at 3 different levels. You can do it at the VPC level, you can do it at an actual subnet level, and then you can go all the way down to your network interface level, so down to your ENIs as well. So let's have a look at how this works in the AWS console. Okay, so I'm in the AWS console. We need to go over to our VPC, which is under Network Content and Delivery. And then what we're going to do is we're going to go to our VPCs and we're going to select our custom VPC. And we're going to go over to Actions and we're going to go ahead and hit Create Flow Log. Now we have our different filters in here. We could just go ahead and if you're uncertain what it means, just click up here. But this is basically the type of traffic to be logged. So you can choose all to log accepted and rejected traffic, or you can just choose to accept to log rejected traffic or accepted traffic only. I'm going to go ahead and select all. I want to go ahead and log everything. Now, in terms of your destination, you can send it to CloudWatch logs or you can send it to an S3 bucket. I'm going to send it to CloudWatch logs. In here, it says destination log groups. You have to go in and enter your log destination group. Because we haven't done it, we're going to have to go over to CloudWatch. So let's go over here and we're going to always find CloudWatch under management and governance. And we're going to have to create a new log group for this. So to do that, all we need to do is go over to our logs. And what we're going to do is go in and say, let's get started. And we're going to go in and create a log group. And I'm going to call this VPC Flow Logs. And that's my log group in there. Now that we've done that, we just go back to VPC, which is under Network Content and Delivery. And we'll go back to our VPCs and we'll click in here and we'll go to our actions. And then we're going to go ahead and hit Create Flow Log. Again, I'm just going to change this back to all, and then we're going to see our VPC flow logs in there. IAM role, we haven't actually created an IAM role for this yet. So what you can do is just click here, set up permissions. That will then open up a new tab for you, and you're just going to create a new IAM role. We're going to call it flow logs role. You can see the policy document in here, but I'm just going to go ahead and hit allow. And then that will take me back to my VPC section, which was a little bit frustrating. But if you just open up the old tab, you should now be able to see it in here. And you might just have to click in here to refresh it. But there we go, flow logs roles. And so now I'm going to go ahead and create my flow log, and my flow log has now been created. So that is now sending all my traffic to my CloudWatch logs groups. If I go back over to here, we can go into CloudWatch. And so basically it's monitoring all IP traffic, and it's going to be in here logs, and you'll be able to see it in there. Now it will take a while for this to propagate. You can go ahead and force the logs to propagate by just going and visiting your website and refreshing. My network ACL is still blocking my public IP address, so that should hopefully be logged in the flow logs. And I've just gone back to my flow logs, and I can see that it's been logged in here. I can go and look at the log stream, and this is the data in here. So we can see essentially this IP address is now trying to access our private IP, and it's being rejected. And don't worry, you don't really need to know how to read this for the Certified Solutions Architect Associate exam. You definitely need to understand it for both advanced networking and security specialty. So we do cover it in a lot more detail in those courses. So onto my exam tips. Just going into your exam, remember the following. You cannot enable flow logs for VPCs that appeared with your VPC unless the peer VPC is in your account. So in other words, you can definitely have VPC flow logs between peered VPCs, but they need to be within the same AWS account. You can't do this across accounts. You can now tag flow logs, so you can attach tags to your flow logs. And after you've created a flow log, you cannot change its configuration. For example, you can't go in and associate a different IAM role with the flow log. You know how we can change IAM roles with EC2? Well, you can't do that with flow logs. Once you create the flow log and set its configuration, that's it. It's set in stone. Also remember that not all IP traffic is monitored. Traffic generated by instances when they contact the Amazon DNS server, that's not going to be monitored. If you use your own DNS server, then all traffic to that DNS server will be logged. Traffic generated by Windows instances for Amazon Windows licensing activation is not going to be monitored. And then traffic to and from 169.254.169.254 for instance metadata. If you remember, we did that in the EC2 section of the course. And then DHCP traffic is not monitored as well as traffic to the reserved IP addresses for the default VPC router. So that is it for VPC flow logs. Very, very straightforward. In the next lecture, we're going to compare NATs versus Bastions, and then we're going to go on to VPC Endpoints, and then we've finished the VPC section of the course. So if you've got the time, please join me in the next lecture. Thank you. Okay, hello Cloud Gurus, and welcome to this lecture. This is just a theoretical lecture to explain what Bastion hosts are. So what is a Bastion host? So this is the Wikipedia definition of a Bastion host, and it says that it's a special purpose computer on the network specifically designed and configured to withstand attacks. And the computer generally hosts a single application, for example, a proxy server, and all other services are removed or limited to reduce the threat to this computer. It is hardened in this manner primarily due to its location and purpose, which is either on the outside of a firewall or inside a demilitarized zone. And what do they mean by demilitarized zone? Well, basically public subnet. And it usually involves access from untrusted networks or computers. So let's have a look at a Bastion host in action. So in here, we've got our public subnet, which is here, and we've got our private subnet in here. And let's say that we have a NAT instance. Our NAT instance is behind a security group. And let's also say we have a NAT gateway. And you could have one or the other, but the difference is obviously NAT instance is an individual EC2 instance, which is behind a security group. And then the NAT gateway doesn't need to be behind a security group. And this is much more redundant. It's not a single instance. So when our instances in our private subnets need to access the internet, they do so via either a NAT instance or a NAT gateway. So that's when they're downloading patches or installing software, etc. But if we need to go in and administer this environment, what would typically happen? I've got SSH or RDP, so SSH for Linux or RDP going to Windows. And essentially what it's doing is it's going through the internet gateway, it's going through our route tables, it's going through our network ACLs, it's going through our security groups, and then it's going on to our Bastion server. And then our Bastion server basically just forwards the connection through SSH or through RDP to our instances. And then in this scenario, all we need to do is harden our Bastion host. We need to harden as strongly as possible because that's what's going to try and be hacked. And then we don't have to worry about hardening our instances in our private subnet. So long as our Bastion host is hardened, that makes it a lot easier. We're basically reducing the surface area in which we need to harden. So that's all a Bastion is. It's a way of SSHing or RDPing into your private instances, in your private subnets. And you essentially just focus on hardening this Bastion host. And you can get Bastion host AMIs from the AWS AMI community marketplace as well. So in terms of Bastion host, just remember the following. A NAT gateway or a NAT instance is used to provide internet traffic to EC2 instances in private subnets, so that it's not being used to SSH or RDP in. A Bastion is used to securely administer EC2 instances, so using SSH or RDP. Bastions are also called jump boxes in Australia. So if you're an Australian watching this and you're wondering, this sounds exactly like a jump box, that's exactly what it is. They're the same thing. And then you cannot use a NAT gateway as a Bastion host. So if you are going to be RDPing or SSHing into your instances in private subnets, you need to go in and configure a Bastion host. You can't do it through a NAT gateway. That is it for this lecture, everyone. In the next lecture, we're going to have a look at Direct Connect. So if you've got the time, please join me in the next lecture. Thank you. Okay, hello Cloud Gurus and welcome to this lecture. This is a really quick theoretical lecture on Direct Connect. So what is Direct Connect? Well, Direct Connect is basically a cloud server solution that makes it easy to establish a dedicated network connection from your premises to AWS. And using AWS Direct Connect, you can establish a private connectivity between AWS and your data center or your office or a co-location environment, which in many cases can reduce your network costs, increase bandwidth throughput, and provide a more consistent network experience than internet-based connection. So essentially, it is a direct connection into AWS. It's done on dedicated lines. And this is a very simple diagram. Let's have a look at it in a more complicated setting. So we've got our AWS region, and inside we have our AWS public services. So this could be things like S3, for example. And then we've also got our VPCs, and this could be a private VPC. Then we have our direct connects locations, and these are spread all over the world. And then essentially we have our customer environment. So this could be our own data center. And inside our Direct Connect location, we have a cage which is dedicated to AWS. And inside that cage, we have Direct Connect routers. And then inside that location, where our customer will also have to have their own cage, or you could use an AWS partners cage. And inside that cage, they're going to have their own customer routers as well, or partner router as well. And then what happens is you've got your router over here inside your own data center, and then you're going to basically have a link, a dedicated link from your data center. And AWS have their own backbone network as well. And from their backbone network, they're connecting their Direct Connect routers through a Direct Connect connection. And then we have what's called a cross connect. And this is essentially a network cable that's connecting our Direct Connect routers to our customer or our partner routers. And then we have our own, basically our own dedicated links. So this is our last mile extension. So this could be an MPLS circuit or dedicated line, etc. And what happens is we run a connection from our own data center all the way up through our customer or partner routers. That then cross connects into the Direct Connect routers, and then has a dedicated connection to the AWS public services. So this could be things like S3. And then we also get a dedicated connection into our VPC. So this isn't traversing the internet at all. It's a direct connect connection through a dedicated line into our own cage or into a partner's cage, through a cross connect, and then into the Direct Connect routers, which then goes over the AWS backbone network into AWS. So that's all Direct Connect is. It is pretty simple, and all you need to really understand what it is going into the exam is that basically what Direct Connect actually is. So it's a Direct Connect connection into AWS data centers, and it's useful for high throughput workloads. So if you've got really high volumes of network traffic, you probably do want to use Direct Connect. And it's also useful if you need a stable and reliable and secure connection. So going into your exam, just remember what Direct Connect is at a high level. And if you've got a scenario-based question where you're trying to do a VPN connection, it keeps dropping out because of the amount of throughput, and what kinds of things could you do to solve that, we'll go ahead and use Direct Connect. So that is it for this lecture, guys. If you have any questions, please let me know. If not, feel free to move on to the next lecture. Thank you. Okay, hello Cloud Gurus, and welcome to this lecture. In this lecture, we're going to look at how we can set up Direct Connect. Now, full disclosure, I do not have a Direct Connect connection, so I can't actually show you how to do it, but I can tell you the steps, and then I can point you in the direction of an AWS video where they actually go through this in the console. So the steps to setting up Direct Connect is you create a virtual interface in the Direct Connect console. This is a public virtual interface. You start with a public virtual interface. Then you go to the VPC console and then to VPN connections, and you create a customer gateway. Then you create a virtual private gateway, and you attach the virtual private gateway to the desired VPC. It's very much like attaching an internet gateway to the VPC, but instead of an internet gateway, it's a virtual private gateway, and you attach that to the VPC. Then you go down to select VPN connections, and you create a new VPN connection, and then you select the virtual private gateway and the customer gateway that you set up earlier in step 2. And then once the VPN is available, you set up the VPN on the customer gateway or firewall. Now, you will need to know these steps going into the exam. They do test on this now, so please try and memorize this as best you possibly can. I would go and watch this YouTube video. I put this in the resources section of the course. This will show you exactly how to do it. It's about 7 and then about 8 minutes long in length, but it will show you exactly how to do it in the AWS console. I wish I could show you myself, but like I said, I don't have a Direct Connect connection at my house, unfortunately. So that is it for this lecture, everyone. Just remember, going into your exam, the steps required to creating a Direct Connect connection. So you create a virtual interface in the Direct Connect console. This is going to be a public virtual interface. Then you go to the VPC console and then to VPN connections and create your customer gateway. So first you create your public virtual interface, then your customer gateway, then you create a virtual private gateway, and that's basically like your internet gateway, and you just attach that virtual private gateway to the desired VPC. Then you go into VPN connections, create a new VPN connection, and then you select the virtual private gateway that you want to use for that VPN connection, as well as the customer gateway. And once the VPN is available, all you need to then do is set up the VPN on the customer gateway or firewall. Again, apologies for not having a Direct Connect connection that I could show you this with, but so long as you remember those steps going into the exam, you are going to pick up 1 or 2 points. If you have any questions, please let me know. If not, feel free to move on to the next lecture. Thank you. Okay, hello Cloud Gurus, and welcome to this lecture. In this lecture, we're going to look at Amazon's Global Accelerator. So what is Global Accelerator? Well, it's a service in which you create accelerators to improve the availability and performance of your application for local and global users. And Global Accelerator directs traffic to optimal endpoints over the AWS global network. And this improves the availability and performance of your internet applications that are used by a global audience. By default, Global Accelerator gives you 2 static IP addresses that you associate with your accelerator. And alternatively, you can bring your own IP addresses. Let's go over to the AWS website and have a look at a diagram. Okay, so I'm on the AWS Global Accelerator landing page, and here you can see how it works. So you've got your user, and you've got traffic from your user's clients is being sent to the AWS Global Accelerator, and it's going via an edge location. So your user's traffic enters the AWS network at the closest edge location, and then AWS Global Accelerator directs traffic to the optimal endpoint based on proximity to the client, as well as health, and then endpoint weights. And we'll cover this all off in a few slides. So you've got these endpoint groups. They're associated with a particular AWS region, so US East 1, US West 1, etc. And we'll cover that off in a couple of slides. And then you've got your actual endpoints themselves. And this could be things like application load balancers or EC2 instances, etc. And so in terms of how it's better, I mean, this is the way you would access the website without Global Accelerator. So you've got your users, they're using their local ISP, And essentially, it's using DNS to resolve a domain name. It's going across a whole bunch of different ISPs and backbone networks. It's all rooted using BGP. Eventually, it hits the AWS region, and it's reliant on a whole bunch of other, providers. With Global Accelerator, you've got your users. They then connect to the AWS nearest edge point, which goes straight into the Global Accelerator and goes over Amazon's backbone network. So you're using the Amazon or the AWS network. So it's a lot more efficient than going across multiple ISPs, across multiple countries, etc. So Global Accelerator includes the following components. We've got our static IP addresses, which we covered off already. Either AWS supplies them or you can bring your own. We then have our accelerator. When we set up our accelerator, we're going to get a DNS name. We've got our network zone, our listener, our endpoint group, and then finally our endpoint, and we'll cover off each one. So let's start with the static IP addresses. Like I said, Global Accelerator provides you with 2 static IP addresses that you can associate with your accelerator, or you can bring your own. We then have our accelerator themselves, and an accelerator directs traffic to optimal endpoints over the AWS global network to improve the availability and performance of your internet applications. And each accelerator includes one or more listeners. When you create an accelerator, what's going to happen is it's going to assign you a default DNS name or domain name system, and it's going to be similar to this example. So I've just entered a random one, and then it's .awsglobalaccelerator.com. And that points to the static IP addresses that Global Accelerator assigns to you. And depending on the use case, you can use the accelerator's static IP addresses or DNS names to route traffic to your accelerator, or you can set up DNS records to route traffic using your own custom domain names as well. Then we've got our network zone, and our network zone services the static IP addresses for your accelerator from a unique IP subnet. So it's very similar to an AWS availability zone. A network zone is an isolated unit with its own set of physical infrastructure. So when you see network zone with Global Accelerator, I want you to just think of an availability zone. And when you configure an accelerator by default, Global Accelerator allocates 2 IPv4 addresses for it. If one IP address from a network zone becomes unavailable due to IP address blocking by certain client networks or network disruptions, client applications can retry on the healthy static IP address for the other isolated network zone. So if you lose one network zone, you can use the other IP address in another network zone. We then have our listener. A listener processes inbound connections from our clients to Global Accelerator based on the port or port ranges and protocols that you configure. And Global Accelerator obviously is going to support TCP and UDP protocols. And each listener has one or more endpoint groups associated with it, and then traffic is forwarded to the endpoints in one of the groups. And you associate endpoint groups with the listener by specifying the regions that you want to distribute the traffic to. And then traffic is distributed to optimal endpoints within the endpoint groups associated with the listener. And if this doesn't make a lot of sense to you, don't worry, we're going to cover this off in a lab in a couple of seconds. Our endpoint groups is, each endpoint group is associated with a specific AWS region. So it might be US East 1, US West 1, etc. Endpoint groups include one or more endpoints in the region. And you can increase or reduce the percentage of traffic that would otherwise be directed to an endpoint group by adjusting a setting called the traffic dial. If you have 100% traffic on one endpoint group, then 100% is going to go to that endpoint group. You might have 60% on one endpoint group and 40% on another. And these are traffic dials that you set. And that means 60% will go to one endpoint group, 40% will go to another endpoint group. The traffic dial lets you easily do performance testing or blue-green deployments testing for new releases across different AWS regions. And then we've got our endpoints, and our endpoints are simply things like network load balancers, application load balancers, EC2 instances, or elastic IP addresses. And an application load balancer endpoint can be internet-facing or it can be internal. And then traffic is routed to endpoints based on configuration options that you choose, such as endpoint weights. So you can have weighted endpoints as well. For each endpoint, you can configure weights, which are numbers that you can use to specify the proportion of traffic to each one. And this can be useful, for example, to do things like performance testing within a particular region. So if all this doesn't make a lot of sense, let's go ahead and deploy a global accelerator so you can get some hands-on experience, and then we'll go on to my exam tips. Okay, so here I am in the AWS console. Before we go over to Global Accelerator, the first thing we want to do is create an endpoint. And an endpoint can be our application load balancer or an EC2 instance, etc. So let's go over to EC2 and create an endpoint. So I'm going to just create an EC2 instance. I'm going to go and put it into US East 1. And let's go over and launch our instance. And I'm just going to do everything as default. So I'm going to use an Amazon Linux 2 AMI. I'm going to just do a T2 micro. I'm going to leave everything as default, add our storage, leave the tags, add our security group. I'm going to put this into my WebDMZ security group, and then I'm going to go ahead and hit launch. And that is now launching my EC2 instance. Now that we've done that, we now have a endpoint. So this is where our global accelerator is going to send all our traffic to. Now, let's go over and find Global Accelerator. Where do you think it would be? Well, if you said networking, you're absolutely correct. It is at the bottom of the networking and content delivery section right now. And you'll see here it actually opens up in a new tab when you click on that link. So this is Global Accelerator, and we can go ahead and create an accelerator. You'll see this landing page if you've never created one before. And in here, we just do our basic configuration, which is simply the accelerator name. So I'm going to call mine A Cloud Guru. I'm going to leave everything else as default. In here, we've got our IP address types. I'm going to leave it as IPv4. In here, this is where you bring your own IP addresses. We're not going to worry about that. Let's go ahead and hit next. In here, we can configure our listeners. So what port do we want to listen on? Well, we want to listen on port 80 and then 443, so HTTP and HTTPS. Protocol, UDP or TCP, we're going to do it on TCP. Client affinity, this is very much like sticky sessions with your Elastic load balancers. Essentially what this does is if you have stateful applications, Global Accelerator can direct all requests from a user at a specific client IP address range to the same endpoint resource to maintain client affinity. I'm just going to leave that as none and go ahead and hit next. In here, we've got our endpoint groups. So let's go in and add our region. So when we deployed our endpoint, we did it in US East 1. So I'm going to click in here. If you did want multiple endpoint groups, you could click in here and again, just add an additional endpoint group. I'm not going to do that. I'm just going to send it all to US East 1. We can configure our health checks as well. I'm going to leave everything as default and go ahead and hit next. And in here, this is where we add our endpoint, so where we add our EC2 instance. So go ahead and click Add Endpoint. In here, we choose what we want. Do we want it to be an application load balancer, network load balancer, an EC2 instance, or Elastic IP? Well, I want it to be an EC2 instance. In here, you should be able to see your EC2 instance. And in here, we've got our weight. Now, our weight is just our the endpoint weight. So just like how we could redirect traffic to particular endpoint groups, so you could do 60%, 40%, we can also do individual traffic to our individual endpoints as well. I'm just going to leave it as default as 128. So let's go ahead and hit Create Accelerator. And you can see that is now creating our accelerator. Straight away, we're assigned a static IP address or two static IP addresses, as well as our DNS name. And it really is as simple as that. That's how we create a global accelerator. It can take a couple of minutes to deploy, so I'm going to pause the video. Okay, let's do a refresh. Hopefully it's deployed, and you can see now the status has changed to deployed. In here, we can click into our endpoint and start changing our configurations. At the moment, the listeners are saying that this has a unhealthy status. Of course it does, because when we deployed that EC2 instance, we didn't turn it into a web server. We didn't create index.html. You can do that if you want. It's entirely up to you. And also we can go through and we can edit our configuration in here. Now, to delete our accelerator, all we need to do is click on our accelerators. First, we must disable it, then we delete it. So go ahead and just hit delete and disable your accelerator. This can take up to 5 minutes. I'm just going to pause the video, wait for it to be disabled. So my accelerator has now been disabled, and all I need to do is type in delete in here to go ahead and delete it. And there we go. It is now being deleted. If you go in and refresh it, you'll see that it says in progress, and then eventually it will disappear. Let's go over to my exam tips. So onto my exam tips. For the Certified Solutions Architect Associate exam, you basically just need to know what a global accelerator is and where you would use it. So Global Accelerator is a service which you create accelerators to improve availability and performance of your application for both local and global users. Remember that you always assign 2 static IP addresses, and alternatively you can bring your own, and then you can control the traffic using traffic dials, and that's what we did in the lab, and that is done on the endpoint group itself. And you can also do traffic weighting on individual endpoints as well, so it's very highly configurable. So that is it for this lecture, everyone. If you have any questions, please let me know. If not, feel free to move on to the next lecture. Thank you. Okay, hello Cloud Gurus, and welcome to the very last hands-on lecture in the VPC section of the course. We're going to learn all about VPC endpoints, and in the next lecture we're going to go in and summarize everything that we've learned about VPCs. So here is the age-old question: what is a VPC endpoint? So VPC endpoint enables you to privately connect your VPC to supported AWS services and VPC endpoint services powered by PrivateLink without requiring an internet gateway, a NAT device, a VPN connection, or an AWS Direct Connect connection. Instances in your VPC do not require public IP addresses to communicate with resources in the service. So traffic between your VPC and other services does not leave the Amazon network. So it's a way of traversing your traffic without having to leave the Amazon network. You don't need to go over the internet. Endpoints are virtual devices, and they are horizontally scaled, redundant, and highly available VPC components that allow communication between instances in your VPC and services without imposing availability risk or bandwidth constraints on your network traffic. And there's basically 2 types of VPC endpoints. We have our interface endpoints and we have our gateway endpoints. And in this lab, what we're going to do is we're going to create an S3 gateway endpoint. We'll have a look at how we're going to do that a bit later. At first, we should just talk about an interface endpoint. So this is an elastic network interface, or an ENI, with a private IP address that serves as an entry point for traffic destined to a supported service. So the following services are supported. I'm not going to read them all, but basically a whole bunch of services are supported, and there's probably going to be more and more added throughout 2019 and 2020. Again, don't worry, you're never going to be quizzed on this as to which services are supported, but what you need to know is you basically attach an ENI to an EC2 instance, and that will essentially allow you to communicate to these services using the Amazon internal network. They don't need to then traverse the internet. And then gateway endpoints are very similar. They look just like NAT gateways essentially, and they're supported for S3 and DynamoDB currently. And so what we're going to do is we're going to go ahead and create a gateway endpoint. So right now, this is what our VPC environment looks like. We've got an EC2 instance in a private subnet. We've got one in a public subnet. Our private subnet, when it wants to communicate to S3, it basically traverses through the NAT gateway and then goes outside of the AWS network, and then it uses basically the S3 public endpoints, and that is how it would copy a file. What we're going to do is we're going to change this architecture. We're going to get our instance to send our files to a VPC gateway, and then that gateway is then going to send that file to our S3 bucket, and it will not leave the Amazon network. So let's go ahead and see how we can set this up. You will need to log into the AWS console. If we go over to services, we'll just go down to identity access management and security and compliance. And I want you just to make sure that you've got a role which allows you to talk to S3. Now, for some reason, I must have deleted it at some point. I'm going to go ahead and create the role. See if you can create it yourself from memory. So I'm going to use the EC2 service. I'm going to go ahead and go next. And then I'm going to type S3 in here. So I want S3 full access, and then I'm going to go ahead and hit next. Tags I don't really need, and then I'm going to call this S3 admin access. This will allow EC2 to call S3 on my behalf. I'm going to go ahead and create the role. So I've now created that role. The next thing we're going to do is we're going to go over to EC2, and we're going to add this role to our instance that's in our private subnet. So we're going to do it to my DB server, and we're just going to go over and go to instance settings and change the attach replace IAM role. And then I'm just going to add in S3 in there, and I'm going to go ahead and hit apply. So that has now applied it. Now I do have a couple of network ACLs, network access control lists, and it can be difficult to manage. So what I'm just going to quickly do is just go down to my network ACLs. So I need to find my VPC, and then I'm going to go over to my network ACLs, and I'm just going to quickly move my subnet to my default network ACL. So we've got this web network ACL. I'm going to click on my default subnet. So this is my main or default subnet for this VPC. I'm going to go to my subnet associations and I'm going to edit this and I'm going to go ahead and add this subnet into it as well. And I'm going to go ahead and click edit. So now it's I've only got one subnet that I have to worry about. I don't have to worry about all my different inbound and outbound rules. So I'm just doing that to make this lab a little bit easier. So now that we've done that, what we're going to do is we're going to SSH into the EC2 instance that's in our private subnet, and I'm going to go ahead and try and create a file and just copy it to an S3 bucket. So let's go ahead and grab the IP address. So I need to SSH into my public one, and then I'm going to SSH from my public one over to my private one. So I'm just going to grab this IP address there and see if you can remember. Mine just ends in .235. Okay, so here I am. I'm in my downloads directory. I'm going to SSH EC2 and then -user and then @ and I'm copying and pasting my my public IP address in there. And then I'm going to use my key pair. And so there we go, I've connected. I'm going to elevate my privileges to root, and I'm going to go ahead and clear the screen. Now I should still have my private key in here, which I do from a few lectures ago. And then I'm going to SSH using EC2 -user and then @ and then I'm going to do my private IP address, so 10.0.2 and then I think it was .235. Your private IP address will be different, so make sure you remember what it is. And then I'm going to do my private key pair.pem, and there we go. Going to elevate my privileges to root. Going to clear the screen. Then I'm just going to type AWS S3LS, and I should be able to list all my buckets in there, and you can see that I can do that. And what I could do is I could create a file, so I could just say, let's say echo, and then I'll just say test, and I'm going to output that to test.txt. And again, if I hit ls, we can see that that file has been created. And then I could do AWS S3 and then copy and then test.txt. And then I want to do that to my bucket, and I'm going to do it to the A Cloud Guru. And then it's 2019. And then it's Ryan. And then Kronenberg. And then it's Pi 3.141. And that has now copied it over to my S3 bucket. And just to test that that worked, let's go over to S3 and see that we can see that file. So it's in here, and there we go, test.txt has just been placed in there. So the next thing we're going to do is we could go in and just delete our NAT gateway, or what we could actually do is just remove the root, and that's essentially the same as deleting it because it's got no root to our NAT gateway. So I'm just going to go over to my root table, and what I want to do is I want to grab my main root table and click in here, and you can see here we've got our root out to our NAT gateway. And what we want to do is we want to go in and hit edit routes, and we're going to delete that. So essentially that is now saying we have no route out to our NAT gateway. If I go back over to my EC2 instance, so I'm back in that private EC2 instance, I'm going to go ahead and clear the screen just so it's easier to see. If I now type AWS S3LS, nothing's going to happen because it has no route out to the internet because we've deleted that from our main root table. So what we're going to do now is we're going to go in and add in our own VPC endpoint. So I'm back in the VPC dashboard. You'll be able to go over to endpoints, and we're going to go ahead and create an endpoint. And you can do these different service categories. So you can do it by service, you can find services by name or an AWS marketplace. And what you can do is if you just go down to type, you can see here that's DynamoDB. So that's the DynamoDB gateway. And I want this one. I want the Amazon S3 gateway. And then in here, it's asking me which VPC I'd like to do this for. I'm going to do it for my A Cloud Guru VPC. And then it's going to ask which root table you want to do it to. I'm going to do it to my main root table. So I'm going to click it in here. And the policy, we're going to do full access, and then we're just going to go ahead and hit create endpoint. And that has now created our VPC endpoint, and you can see that it's already available. Now, full disclosure, I went over and clicked on my root table, and when I clicked on my main root, I couldn't actually see the root in there. It took probably about 5 minutes for the root to go in and be set up automatically. So do just wait a little bit. The VPC endpoint's provisioned immediately, but the updating to the root table can take a little bit of time. As soon as you do see that root in there, feel free to go over to your EC2 instance. So I'm back in my EC2 instance. If I type in AWS S3LS, it just looks like it's going to time out, and it's actually just really annoying. I don't know why they do this, but we need to add in another flag now. So we need to say AWS S3 LS, and then we need to specify the region that we're in. So I'm in US East 2 because I'm in the Ohio region. And then that will go ahead and list my buckets. So if you do type AWS S3 LS and it's just hanging, it's not because you don't have a connection, it's just that you have to specify the region that you're in. So now I'm able to see all my buckets and I'm not leaving the AWS network. I'm doing it through my VPC endpoint. So onto my exam tips, just remember what a VPC endpoint is. It enables you to privately connect your VPC to supported AWS services, and there's an awful lot of them, and VPC endpoint services powered by PrivateLink without requiring an internet gateway, NAT device, VPN connection, or AWS Direct Connect connection. And just remember there's two types of VPC endpoints. There's interface endpoints and then there's gateway endpoints. And gateway endpoints are currently supported for S3 and DynamoDB. So that's it for this lecture, everyone. In the next lecture, we're going to look at VPC PrivateLink. We're then going to go ahead and have a look at Transit Gateway and then VPN Hub. We're going to look at networking costs on AWS, and then you have finished with the VPC section of the course. So if you've got the time, please join me in the next lecture. Thank you. Okay, hello Cloud Gurus and welcome to this lecture. In this lecture we're going to look at AWS PrivateLink. So what are some of the ways that we can open up our services in a VPC to another VPC? So here we have our VPC that we've been using so far in this section of the course. We've got our public subnet, our private subnet. Let's say we had an application that sits both within our public subnet and within our private subnet, and we want to make this application available to other services in another VPC. It could be your own VPC or it could be VPCs of one of your end customers. And let's say it's multiple VPCs, maybe in the hundreds or even the thousands. What are some of the ways that we can do this? Well, the first thing is to open up the VPC where the application is hosted to the internet itself. Another way is to use VPC peering, but if we're using tens or hundreds or thousands of different VPCs, we'd have to open up a peering connection to each and every one of them. So both of these options have their disadvantages. So to open our applications up to other VPCs, like I said, we can either open the VPC up to the internet. Some of the disadvantages to this could be security considerations. Everything in the public subnet is going to be public, and you've also got a lot more to manage because you have to be aware that your VPC is now open to the internet. You have to go in and make sure your security groups are effective, that your network ACLs are there. You might have to add in web application firewalls to stop layer 7 attacks, etc., etc. So it can be more difficult to manage. We could also use VPC peering. The issue here is you're going to have to create and manage many different peering relationships. So if you are trying to open your VPC up to say 10 other VPCs or 100 or even 1,000, you're going to have to create each individual peer, and the whole network will be accessible, and this isn't very good if you have multiple applications within your VPC. So Amazon invented PrivateLink, and this essentially allows you to open your services in a VPC to another VPC using PrivateLink, and this is the best way to expose a service VPC to tens, hundreds, or even thousands of customer VPCs, and it doesn't require VPC peering. There's no route tables, NAT gateways, internet gateways, etc., etc. And all it does is it requires a network load balancer on the service VPC and an elastic network interface on the customer VPC. So here we've got our application sitting in our service VPC. We've got our network load balancer. We then, in our customers VPC, we've got an elastic network interface, which is dedicated to their application or service. And then once we've got those two, we essentially take the static IP address of the network load balancer and we open it up to our elastic network interface by creating an AWS PrivateLink. So that's all that AWS PrivateLink is. It's a way of sharing your applications within your own VPC to multiple VPCs at once, and it's the best and most secure way of doing it. So going into the exam, all you need to remember is what AWS PrivateLink is. If you see a question asking about peering VPCs to tens, hundreds, or even thousands of customer VPCs, I want you to think of AWS PrivateLink. It doesn't require VPC peering. There's no route tables. There's no NAT instances or NAT gateways, internet gateways, etc. But it does require a network load balancer to the service VPC and an elastic network interface on the customer VPC. So that is it for this lecture, everyone. everyone. If you have any questions, please let me know. If not, feel free to move on to the next lecture. Thank you. Okay, hello Cloud Gurus, and welcome to this very quick lecture on AWS Transit Gateway. So over the years, as the VPCs and networking services within AWS have grown more and more complicated, so has the network architecture. So this could be a typical network architecture. In the top left-hand corner, we've got our customer gateway. This could be an on-premise data center. It's then connecting out using VPN connections to 3 different VPCs, which all might be in the same AWS account, or it might be across multiple AWS accounts. And then those VPCs need to talk to other internal VPCs. So we've got a whole bunch of VPC peering coming in. And then we might have AWS Direct Connect Gateway from our headquarters or from another off-premise data center that's connecting into this. And it can all get really, really complicated. And this is just, say, within one region. So what Amazon did is they came out with the AWS Transit Gateway. And this is just a way of simplifying your network topology. It's basically a single point in which all your different network connections can connect into. So whether it be your VPN connections, your AWS VPCs, or even Direct Connect, it all hits Transit Gateway, and then it operates on a hub and spoke model. So you don't need to do all this inter VPC peerings, etc. So really all you need to do going into the exam is understand what Transit Gateway is. It allows you to have transitive peering between thousands of VPCs and on-premise data centers. It works on a hub and spoke model. It works on a regional basis, but you can have it across multiple regions, and you can use it across multiple AWS accounts using Resource Access Manager, and we will cover that off later on in the course, what RAM is. And you can use route tables to limit how VPCs talk to each other inside Transit Gateway, and then it also works with Direct Connect as well as VPN connections. And then finally, it supports IP multicast, and that's not actually supported by any other AWS service. So when going into your exam, if you're given a scenario question where it's talking about how you can simplify your network topology, maybe you've got hundreds of VPN connections coming in, direct connect connections, you've got a whole bunch of VPC peering going on, and you also need to support IP multicast, I want you to think of immediately of Transit Gateway. That's all it is. It's a way of simplifying your network architecture or topology, and it always uses a hub and spoke model. So that is it for this lecture, everyone. If you have any questions, please let me know. If not, feel free to move on to the next lecture. Thank you. Okay, hello Cloud Gurus, and welcome to this lecture. This is a really quick theoretical lecture on a new service called AWS VPN CloudHub. Essentially, all you need to know for the exam is what it is and what it does. So let's say we've got our VPC here. It's got a couple of EC2 instances in different subnets, and then we've got 3 different sites. We've got our site in New York, our site in Los Angeles, and our site in Miami. And essentially what we want to do is be able to connect in to our VPC using VPN connections. And what you would use is the way to keep the network architecture the most simple is by using AWS VPN CloudHub. Essentially, this would allow our users all to connect into a single virtual private gateway. And then your customers in New York would be able to talk to your VPC over an encrypted VPN. And they would also be able to communicate from New York through your VPN CloudHub to Miami. So it's a hub and spoke architecture. So they have direct VPN connections via your VPC from New York to Miami and also to Los Angeles. So that's all VPN CloudHub is. It's just a way, it's a single basically point of contact to connect your VPN infrastructure into. So if you have multiple sites, each with its own VPN connection, you can use AWS VPN CloudHub to connect those sites together. Like I said, it's a hub and spoke model. It's low cost, it's really easy to manage, and it operates over the public internet. But of course, being a VPN solution, all traffic between the customer gateway and the AWS VPN CloudHub is encrypted. So literally, you just need to know what it is going into your exam. If you see a scenario talking about how you can essentially, what's a good way to manage your multiple sites with VPNs, definitely consider VPN CloudHub. So that's it for this lecture, guys. If you have any questions, please let me know. If not, feel free to move on to the next lecture. Thank you. Okay, hello Cloud Gurus and welcome to this lecture. This is one of the last lectures in the VPC section of the course. Congratulations for getting this far. I'm sure you've learnt an awful lot about VPCs. One of the things you will see in the exam is going to be different scenario questions, and it will be about cost optimization for your VPC architecture. So you still need to know at a high level how AWS network costs work. So I'm going to go through an example network cost diagram. I'm just going to use pretend figures just to keep the network simple, but you should be able to follow along. So let's say we've got our user and they want to connect in to a VPC. So every time they speak to let's say it's a web server inside our VPC, the traffic coming in is going to be free. So they're doing a GET request or something. That initial request coming into the VPC is going to be free. Your web server is then going to go ahead and connect up to, let's say it's a database server, a MySQL server. Now, if it's using a private IP address and it's in the same availability zone, then that data is going to be free. If, however, you're connecting in across another availability zone, you will be charged 1 cent per gig. And again, I'm just giving you an example cost. It depends on the region, depends on the different regions in the world. So the cost can vary, but let's just use an example here of say 1 cent per gig. So you're going to pay an amount of money for communication across private IP addresses from one availability zone to the other. And if you're going outside your availability zones, if you're using a public IP address, that's then going to traverse the internet. And for example, it's going to be twice as expensive than doing it through an internal IP address across your availability zones. And for the reasons for that is you're using the AWS backbone network when you're connecting from availability zone A to zone B using the private IP address. But if you're using the public IP address, you're coming out of the VPC, you're going across the internet and you're coming back in. So you're going to incur a larger cost doing it that way. And let's say we've got VPC B, which is in another region as well, and we need to communicate from VPC A in one region to VPC B in another region. Well, you are going to pay inter-region costs. So it is going to be more expensive than communicating from one availability zone to the other within a single region. It's essentially going to cost you more to do region to region intercommunications between your VPCs. So going into the exam, just remember that you should always use private IP addresses over public IP addresses where possible to save on costs. This is then going to utilize the AWS backbone network. If you want to cut all your network costs, then group your EC2 instances inside the same availability zone and use private IP addresses. This will be 100% cost-free, but bear in mind that you're going to have a whole bunch of single points of failure issues. So if your availability zone goes down, you are going to lose your entire application. So those are the two things to remember going into the exam. Remember, if you do see a scenario-based question where it's talking about cost optimization, you always want to use private IPs over public IPs. And if you want to cut all your network costs, then just put everything inside the same availability zone. So that is it for this lecture. Congratulations, you've done really, really well. In the next lecture, we're just going to summarize everything we've learned in VPCs, and then we're ready to move on. So if you've got the time, please join me in the next lecture. Thank you. Okay, hello Cloud Gurus and welcome to this lecture. This is the final lecture in the VPC Summary section of the course. Congratulations, you've done really, really well to get this far. Hopefully you have a deep understanding of VPCs now. And I would honestly go back and until you can build a VPC from memory with both public and private subnets, as well as with VPC endpoints and NAT gateways, until you can do it all by memory, I would not go and sit the exam. So long as you can do all this by memory, you will almost certainly pass the AWS Certified Solutions Architect Associate course. And also, if you can build out a VPC from memory, you're going to kill any job interview because you know exactly what to do. So let's start with VPC overviews and remember the following. So we thought of a VPC as a logical data center in AWS, and it consists of internet gateways or virtual private gateways, route tables, network access control lists, subnets, and security groups. Remember that one subnet always equals one availability zone, and remember that security groups are stateful. Network access control lists are stateless. So with our security group, all we need to do is go and open up a port, might be port 80 or port 22, and we didn't need to worry about our outbound traffic. It was all automatic. With network access control lists, we have to do both inbound and outbound. Also remember that you can't do transitive peering with VPCs. They need to be peered on a one-to-one basis, and you can peer between regions. So we then went on to build out our very first VPC, and when we created our VPC, it created a default route table, it created a default network access control list, and it created a default security group. It won't create any subnets, nor will it create a default internet gateway. And just remember that US East 1A in your AWS account can be a completely different availability zone to US East 1A in another AWS account. So the availability zones are randomized between AWS accounts. Remember that Amazon always reserves 5 IP addresses within your subnets. And remember that you can only have one internet gateway per VPC. You can't just go in and add multiple internet gateways to your VPC. You can only have one. Also remember that security groups cannot span VPCs. We then went on to learn about NAT instances. So when creating a NAT instance, you always disable the source and destination check on the instance. NAT instances must be in a public subnet, and there must be a route out of the private subnet to the NAT instance in order for this to work. And that the amount of traffic that a NAT instance can support depends on the instance size. And if you're bottlenecking, what you need to do is you need to go in and increase the size of the NAT instance. And you can create high availability using auto-scaling groups, multiple subnets in different availability zones, and then a script to automate failover. And NAT instances are always behind a security group. To be honest, you don't really want to use NAT instances in the real world. You pretty much always want to use a NAT gateway. And just remember how a NAT gateway works. Essentially, you've got your instance here. It has a route in its route table to the NAT gateway, and the NAT gateway has a route out to the internet. And so when your instance runs a yum update, it's going to the NAT gateway and then traversing out to the instance. And also note that your NAT gateway is not behind a security group. It exists on its own. In terms of NAT gateway, redundancy is available inside the availability zone. It's preferred by the enterprise. It starts at 5 gigabits per second, scales currently to 45 gigabits per second, probably scale even more in the future. You don't need to worry about patching NAT gateways, and they're not associated with any security groups, and it's automatically assigned a public IP address. And when you add your NAT gateway, just remember to update your route table so it has a route out to an internet, and you don't need to worry about disabling source destination checks on a NAT gateway. Also remember that if you have resources in multiple availability zones and they share the one NAT gateway, in the event that that NAT gateway availability zone goes down, resources in the other availability zones are going to lose internet access. So just by having a single NAT gateway, you do not have high availability. To create an availability zone independent architecture, what you have to do is create a NAT gateway in each availability zone and configure your routing to ensure that resources use the NAT gateway in the same availability zone in which they're in. Also remember, moving on to network ACLs, so your VPC automatically comes with a default ACL, and by default it allows all outbound and inbound traffic. You then can create custom network ACLs, and by default when you do this, each custom network ACL denies all inbound and outbound traffic until you go in and add rules. And each subnet in your VPC must be associated with a network ACL, and if you don't explicitly associate a subnet with a network ACL, then the subnet is automatically associated with the default network ACL. And you can block IP addresses on specific ports using network ACLs. You can never do this using security groups. Remember that you can associate a network ACL with multiple subnets. However, a subnet can be associated with only one network ACL at a time. And when you associate a network ACL with a subnet, the previous association is removed. And remember that network ACLs contain a numbered list of of rules, and these are evaluated in order, starting with the lowest number first. And you remember, if we had an allow and then a deny, the allow is going to trump the deny because it's evaluated first. So you must always, if you're going to deny something, you must put it in front of your allow rule. So network ACLs have separated inbound and outbound rules, and each rule can either allow or deny traffic. You can't do that with security groups. And network ACLs are stateless, so responses to allowed inbound traffic are subject to the rules for outbound traffic and vice versa. Moving on to ELBs and VPCs, just remember that you need a minimum of 2 public subnets to deploy an internet-facing load balancer. Moving on to VPC flow logs, just remember the following. You cannot enable flow logs for VPCs that appeared with your VPC unless the peer VPC is in your account. So you can't have flow logs across multiple AWS accounts. You can have them across multiple VPCs, but they have to be within the same account. You can now tag VPC flow logs, and after you've created a flow log, you cannot change its configuration. For example, you can't associate a different IAM role with the flow log. You could do that for EC2, but you can't do that with flow logs just yet. Remember that not all IP traffic is monitored with flow logs, so traffic generated by instances when they contact the Amazon DNS server is not going to be logged. If you use your own DNS server, however, then all traffic to that DNS server is going to be logged. Traffic generated by a Windows instance for Amazon Windows license activation is not going to be monitored. Traffic to and from 169.254.169.254 for your instance metadata and user data is not going to be monitored. And then DHCP traffic is not going to be monitored as well. And traffic to the reserved IP addresses for the default VPC router will not be monitored as well. Bastions, just remember what a bastion is and how it works. So we've got our instance in a private subnet. If it wants to connect out to the internet, it's going to do that using a NAT instance or NAT gateway. If, however, we want to SSH in or RDP into our instances in our private subnet, we do that via a bastion host, and sometimes these are called jump boxes as well. So just remember that a NAT gateway or NAT instance is used to provide internet traffic to EC2 instances in private subnets. A bastion is used to securely administer EC2 instances using SSH or RDP, and like I said, bastions are called jump boxes in Australia. And you cannot use a NAT gateway as a bastion host. Moving on to Direct Connect, just remember what it is. It directly connects your data center to AWS, and it's useful for high throughput workloads, i.e. lots of network traffic, or where you need a stable and reliable and secure connection. Also remember the steps to creating a Direct Connect connection. Go ahead and watch that YouTube video that I linked in that lecture. Like I said, I don't have a Direct Connect connection, so I can't actually show you myself, but Amazon have kindly released one on YouTube. So the first thing you do is you create a virtual interface in the Direct Connect console. This is known as a public virtual interface. You then go to the VPC console and then to VPN connections, and you create a customer gateway. You then create a virtual private gateway, and you attach the virtual private gateway to the desired VPC, very much like how you would attach an internet gateway. You then go to VPN connections and create a new VPN connection, and then select the virtual private gateway and the customer gateway. And then once the VPN is available, you need to set up the VPN on the customer gateway or firewall. Moving on to Global Accelerator. Basically, for the exam, all you need to know is what it is and where you would use it. Essentially, it's a service where you create accelerators, and these improve availability and performance of your application for local and global users. And what's happening is your user is going to the AWS Edge network, and then it's traversing AWS's own internal backbone network to get to your EC2 or to your application load balancers or to your different endpoints, etc. So you get a lot more reliability. When you create a global accelerator, you're assigned to static IP addresses. You can also bring your own, and you control traffic using traffic dials, and this is done within the endpoint group. And an endpoint group will then point to different endpoints, and an endpoint is just things like an application load balancer, a network load balancer, it could be an EC2 instance or an elastic IP address as well. And you can also control weighting to the individual endpoints using weights. And then finally, we move on to VPC endpoints, and VPC endpoints enable you to privately connect your VPC to supported AWS services and VPC VPC endpoint services powered by PrivateLink without requiring an internet gateway, NAT device, VPN connection, or AWS Direct Connect connection. And instances in your VPC do not require public IP addresses to communicate with resources in the service. Traffic between your VPC and the other services does not leave the Amazon network. So this is what it looks like. We've got our instance. It then connects to our VPC gateway, which then connects on to our AWS services. So this could be S3 or DynamoDB. And there's two types of VPC endpoints. So we've got our interface endpoints, and that has a whole bunch of different services that you can connect into. But then we've got our gateway endpoints, and our gateway endpoints are only support two services, S3 and DynamoDB. So moving on to AWS PrivateLink, we had a network diagram in here. Just remember, if you see a question asking about peering VPCs to tens, hundreds, or even thousands of customer VPCs, I want you to think of PrivateLink. It doesn't require VPC peering, and there's no route tables, NAT gateways, internet gateways, etc. All it does is it requires a network load balancer on the service VPC, so you can see it in here, and then an ENI on the customer VPC. So if you see anything about peering to multiple VPCs and you want the most efficient way possible, think of AWS PrivateLink. Moving on to Transit Gateway. Transit Gateway is a great way of basically simplifying your network topology within AWS. It works on a hub and spoke model. You can connect to your different VPCs via Transit Gateway, VPN connections, Direct Connect, etc., etc. So it allows you to have transitive peering between thousands of VPCs and on-premise data centers. Like I said, it works on a hub and spoke model. It works on a regional basis, but you can have it across multiple regions, and then you can use it across multiple AWS accounts using RAM or Resource Access Manager, and you can use route tables to limit how the VPCs talk to each other, and it also works with Direct Connect as well as VPN connections. And of course, it supports IP multicast, which is not supported by any other AWS service at this time. So if you see a question talking about basically simplifying your network topology, being able to support multicast, working on a hub and spoke model, I want you to think of Transit Gateway. We then had AWS VPN CloudHub. This is again a way of just simplifying your VPN connections. So you basically put in VPN CloudHub here, and essentially it will allow your customers in New York to talk from site to site. So we'll be able to talk from New York to your VPC over a VPN connection, but then they'll also be able to speak to the network in Miami over another VPN connection. It's basically a way of concentrating or making a hub out of your VPNs. So if you have multiple sites, each with its own VPN connection, you can use AWS VPN CloudHub to connect those sites together. Like I said, it's a hub and spoke model. It's low cost, it's really easy to manage, and it operates over the public internet, but all traffic between the customer gateway and the VPN CloudHub is going to be encrypted. And then very last one was just about network costs and how networking works. So we just saw that in the last lecture. Use private IP addresses over public IP addresses to save on costs when you're doing communication within your VPC. This is then going to utilize the AWS backbone network. If you want to cut all your network costs, go ahead and group your EC2 instances in the same availability zone and use private IP addresses. This is going to be cost-free, but make sure that you bear in mind single points of failure issues. So you've done really well. This is the most complicated part of the entire course. Going into the exam, I would 100% recommend learn how to build a VPC from memory and make sure your instances in a public subnet can communicate to your instances in a private subnet, and your instances in a private subnet have a way of doing yum updates. If you can build out a VPC from memory and deploy instances in public and private subnets again from memory, you are going to smash the exam. You're basically going to get all the networking components right, and the networking components make up a huge part of the exam. So I highly recommend going into the console, playing around, build your own VPC from memory, and make sure that you know how to get your EC2 instances in private subnets able to do yum updates, and then you absolutely kill the networking components of the exam. So congratulations, you're at the end of this section of the course. Like I said, is the most complicated. I hope you had lots of fun, and if you got the time, please join me in the next section. Thank you.